So from page 325, number 61. Natural log of the absolute value of sine of x. Find the derivative of the function. Hold on, let me get this to stop focusing crazy. There we go. Find the derivative of the function. So, pink triangle. Natural log is 1 over the pink triangle times the derivative of the pink triangle. So 1 over absolute value of sine x times derivative of sine x. So I'm not so sure about the absolute value business, but I know the derivative of sine is cosine. So cosine of x. And my guess is that the back of the book probably turns that into cotangent. Let's see, page 25. Number 61. Yep, cosine over sine is cotangent of x. One over the argument times the derivative of the argument. What else? Other questions from 325? Oh, lots more. Yeah.
Can we do 55?
55. Y equals natural log of the natural log of x squared. Oh, we did one kind of like that. So y prime, again, dy dx, y prime, same thing, just going back and forth so you get used to both. So 1 over the pink triangle times the derivative of the pink triangle. So I took care of, if we're thinking chain rule, I took care of that log. Now I need to take care of this log. So the derivative of natural log is 1 over the argument. So it's like, oh, now we got to do a different triangle in here. So 1 over x squared times the derivative of x squared. So it's a 3-link chain rule problem. And one of the x's will cancel, so 2 over x natural log of x squared. And my guess is, I'm watching this person take their test down there. My guess is the book would probably move that 2 to the front. And then the 2's cancel. And so you have 1 over x natural log of x. So again, with the safe stop versus what you'd probably see on the multiple choice or Calc Chat or the back of the book. They like to simplify as much as possible. Julia?
Can you go to 49?
49. Working our way backwards here. Y equals natural log of x square root x squared minus 1. Okay, I'm thinking algebra on this one before we start taking derivatives. So still y equals, not a derivative yet, natural log of x plus natural log of x squared minus 1 to the 1/2. Right, that's algebra rules. Then the 1/2 can come down front. That's still all algebra. I still haven't done any calculus yet. Which is, again, why it's important to label what you're doing. This is all y. Now I'm ready to take a derivative. So dy dx equals 1 over x plus 1/2. 1 over the argument times the derivative of the argument. So x squared minus 1 in the bottom, 2x in the top. That's a perfectly reasonable safe stop. My guess is the book goes further than that. I know CalcChat will go further than that, and since they're tied together, I'm sure they both do more than that. Yeah, they get a common denominator. Well, first the 2's would cancel. 1 over x plus x over x squared minus 1. Again, this was a good safe stop. But if we want to do our algebra skills here, let's see, this one would need an x top and bottom. This one would need an x squared minus 1 top and bottom. So that would be x squared plus x squared is 2x squared minus 1 over x times x squared minus 1. So there's where the back of the book comes up with their answer. Multiple choice CalcChat answer. Rachel, what else? 77. Y equals 2 natural log x plus 3, and something about x, y double prime plus y prime equals 0. Show that the function is a solution of the differential equation. So I want to see that this works in this. So I need to get y prime and y double prime and then plug them in and just see if it works. Not see if it works, it says show that it works. So I know it's supposed to work. So let's find y prime and then y double prime, and then we'll go from there. So y prime would be 2 times 1 over x which is 2 over x. Although since I need to do a second derivative, I'm probably going to write that as 2x to the minus 1. So all of those are equal. It's just depending on the situation or circumstance as to which one is most helpful. But if I need to take another derivative, that last one is what I would be looking at. So the negative comes down front, the power goes down by 1, so negative 2x to the negative 2. And then we could algebra our way back to negative 2 over x squared if we wanted to. Again, kind of just depends on the situation as to which of those is preferable. So now let's plug those into this equation they gave us and see if it works. So x times y double prime plus y prime. I'll go grab that version because that looks like it would be the easiest one to do. Supposed to equal 0. And sure enough, the x is reduced, so negative 2 over x plus 2 over x equals 0. So yes, it works. So 2 derivatives, plug it in to check. Good questions. Anything else?